Okay, let's get the show on the road here this afternoon. Clearly, I'm not Dr. Copeland, but he may be back for class on Thursday, maybe not. If he's not back on Thursday, Dr. Chaffetz will take over for that class meeting. And Dr. Copeland informs me that what he wanted me to do in his absence is to talk about sedimentary rocks, particularly carbonate rocks. I understand you've been wasting your time looking at those nasty igneous and metamorphic rocks that don't hold a torch to these guys. These are by far more interesting things to work with. So, as we see, as we go through today, there are different kinds of sedimentary rocks. The previous slide was shots of the White Cliffs of Dover with chalk, dominantly a carbonate rock, which is the bulk of what I'll be talking about today. And the other group of rocks that we deal with in the sedimentary realm are the original rocks. So here an example of some embedded sandstones and conglomerates with the particle size denoting or giving you information about energy conditions associated with the deposition of those rocks. So before we move into sedimentary rocks in detail, anybody here want to give me the definition of a rock? Any old rock, even those igneous metamorphic things?
Rock. A rock is basically an earth material made up of stuff, doesn't it? It can be organic.
Made up of stuff. Okay. What kind of stuff might a rock be made up of? Okay, so in just giving you a general definition of a rock, it would be made up of minerals. In that case, what other aspect about the definition is important?
It has no set composition.
No, that's true. It doesn't have a set composition, but there's another aspect of what a rock is other than a group of minerals. Well, that's the definition of a mineral that's naturally occurring. If I go down to the beach of Galveston and I pick up a handful of minerals, is that a rock? No, that's sediment. Okay? So the definition of a rock is an aggregate of minerals that are bound together. And the ways in which they're bound together will obviously be predicated on, to a certain extent at least, the way in which they form. So igneous rocks, the minerals in an igneous rock are bound together by virtue of the fact that in the crystallization process coming out of the melt, they interlock to give you the solid end product. So a rock is an aggregate of minerals that are bound together. Okay? That's fine, but we want to talk about sedimentary rocks. Anybody want to venture a definition of a sedimentary rock? Jacob's going to try his stuff on me again.
I can volunteer a lot. A sedimentary rock is a rock that's basically compacted of sediment. The sediment can be large particles, such as those on the earth, can be small particles, such as sand, silt, clay particles. And basically being compacted to the point where they now form a large substance and not fall apart in the hand.
Okay, so he gets into the second part of the definition that we talked about with a general rock, is that whatever makes up a sedimentary rock, those individual parts of that rock have to be bound together. But what are those things? Yeah. Well, I mean, what are the things that are bound together in a sedimentary rock? Are they minerals? Well, okay, so they could be minerals, but what else could they be? Other rocks, fragments of pre-existing rock. So typically, when you look at the definition of a sedimentary rock, you'll find that it's an accumulation of particles of pre-existing rock that are bound together. Okay? And that's correct. Many rocks and sedimentary rocks fall into that definition quite nicely, but not all sedimentary rocks fall into that definition. So what else is missing from the definition? Okay, that's the other category that we have to mess with sedimentary rocks, that the rock itself might be formed from some form of precipitation, biochemically induced or simply chemically induced. Okay? So the definition of a sedimentary rock is somewhat messier than the definition of any old rock, because there are some components that we have to address with sedimentary rocks that make the definition a little messier. There's one other aspect or one other component in the definition of what a sedimentary rock is that we've not addressed at all. Now, when I ask you to consider what that component might be, think about all those other rocks you've been looking at, igneous rocks and metamorphic rocks this semester. How do sedimentary rocks differ from igneous and metamorphic rocks in the most general sense? Pardon? Now, we get to the organic matter in a little bit, yeah. No? Has to be the conditions under which they form, which are low temperature and pressure or surface temperatures and pressures. So sedimentary rocks form at surface temperatures and pressures. Igneous and metamorphic rocks, of course, form at higher temperatures and pressures, and that forms an important component of what makes up an igneous or a metamorphic rock. So sedimentary rocks, and if I get my slide right, okay, so here's kind of the general story. It's an aggregate of minerals or fragments of pre-existing rocks that are bound together, or an aggregate of minerals precipitated from solution. Okay? And then the last part, which we were just talking about, obviously, is that these rocks form at surface temperatures and pressures. That's not strictly true, because what happens is, after the sediment accumulates and gets buried, as it gets buried, it comes under elevated pressures and temperatures because of just the geothermal gradient that you're dealing with when you bury things to depth. But in general terms, we are talking at temperatures that are lower, temperatures and pressures that are lower than would, for instance, cause metamorphism to occur. So low temperatures and pressures, or surface temperatures and pressures, is a good kind of component to the definition. So then the next question becomes, well, okay, where do we get this stuff from? Right? Where do we get the fragments of pre-existing rock? Where do we get the materials that precipitate out of solution? And the aspect of sedimentary rocks that's of importance, of course, is that they are derived from pre-existing rocks by definition. And the pre-existing rocks, of course, can be igneous, metamorphic, or sedimentary. Doesn't matter. And we derive those materials through a variety of processes. The two listed here, weathering and erosion. Okay, weathering and erosion are the processes that generate the particulate material, the fragments of pre-existing rock, and the materials that go into solution to produce the chemically or biochemically induced precipitates that are legitimately defined as sedimentary rocks. Interestingly enough, of course, is the material in solution can precipitate out of solution to give rise to a rock in its own right, but a fairly common aspect of sedimentary rocks is the material that precipitates out of solution around the fragments of pre-existing rock that ultimately sticks the particles together, which is an important component of the definition, of course, because otherwise it would be sediment. When you stick the sediment together, it becomes a sedimentary rock. So those sedimentary rocks that are made up predominantly of fragments of pre-existing rock are cemented together by materials that precipitate out of solution. So they form part of the generation and definition of what a sedimentary rock is. So the solid products that we've been talking about, the fragments of pre-existing rock, are generally the products of the weathering process, either mechanical and to a lesser extent chemical weathering. So these fragments, these solid fragments that are generated by the breakdown of pre-existing rock, those fragments are eroded, transported and deposited before they turn